Welcome to lesson 3 of learning Python by writing the classic game of Snake. Today we're looking at data structures in Python, lists, tuples and dicts. The agenda you can see there on the screen, that's what we'll be covering in the next 10 minutes. There are some links that you can go to. If we go to this particular page here, it's got all the links for all of the course, including the GitHub repo where all the source code is. So let's get started. Here's a very quick recap of where we were at the end of lesson 2. You can see the code on the screen there. We had created a Python game so far that created a game window and a green square snake right in the center. We could press keys to change the color of the snake, R for red, B for blue, and so on. Our objective in this lesson is to get the snake to move when we press the arrow keys, and also to look a bit more like a snake, maybe 3 squares together moving rather than 1 square. Our first job though is to make this code that I've highlighted. This is the if block that listens to the key event and changes the color. We want to make it a bit more Pythonic and elegant. To do that, we're going to replace this if block with a dict. But first we have to understand what dicts are. This is a very short lesson about dicts or dictionaries, but the first thing to note is that we are using a Python notebook file rather than a standard .py file. A notebook file is a very popular way of writing Python because we can put things into cells. So cells can either be, like this one, a markdown cell, where we can write our documentation and comments in a very nice way, or it can be a code cell like this one that we can run and get result. Notice that in a code cell, the very last line of the code cell is printed in the results area below. So we'll see that, and we often won't see print statements. Let's have a look at our dicts. This first statement creates a dictionary. A dictionary is created with curly brackets at the start and at the end. This dictionary has 3 key value pairs. The first pair is got a key of Python and then a value, which is basically a definition of Python, rather like an old paper dictionary here. So that's how we create a dictionary. Once we've got a dictionary, what we want to do is use the key to get the value. So we can use the notation like this. We can say the dictionary name and in square brackets the name of the key. That will bring us back the value. We can have a problem if we use that and our key name is not in the dictionary, in which case we'll get an error. To avoid that, there's a couple of things that we can do. First of all, we can check beforehand if the key is in the dictionary. So if I run this one, Python in terms, it will remain true, but if I would change that to snake, which is not in there, we'll get false. We can also use the get method rather than the kind of slicing notation, indexing notation, and we can pass an argument that in case it's not found. So in this case, Python is there, so it will return the value of Python, but in this case, with snake not being there, it returns found. Let's have a look at the way that we might be using this in our snake game. So the snake game, we kind of listen for certain things. Here I put a dictionary of vowels. It's got a key which is a single letter. It's got a value which is the kind of phonetic name. If I create that there, and then I can say, just like our snake game, it's going to be listening for certain events. So if I come along here and listen for a letter, it's up in here. If I put in an A in there, then it prints that. If I run that again and choose something that's not a vowel, let's say an S, and run that, notice it comes over here. Right, let's apply that to our snake game. First of all, we have to create a dictionary, and I'll come over here and I'll call it key column map. And the AI is helping me here. It is mapping the keys or the Pygame values for each of the keystrokes, and the values are the colors that we can see above. So that's good. We'll take that, and then the next thing is to use it. So we're going to come down to this. We're going to get rid of all of our if loop, and you can see that the AI is helping us. If the event key is in our dictionary, then the color is going to be the value of the event key corresponding to the event key. And let's just tab that. That looks all good. I'll leave that in. I'll leave that print statement in. That's good. So that should work. Let me save that. Let me run it and just make sure it works as it should. So there we are. If I press the R key, the B key. So now we've got a more elegant implementation for changing colors. The next job is to change our geometry. So we think in terms of squares, like the squares on a chessboard, rather than pixels. As you can see here at the moment, we've got kind of the screen size defined in pixels, and we've also got, when we move the snake, we've got the kind of positions and the sizes of the rectangle also in pixels. We want them really in squares. So we're going to create a kind of square size of 20, which will also be the kind of the width of our snake as well as the size of our square. And then we can say that we can calculate the screen size, height and width based on that. So I'll start by setting up a few constants. Here they are. These are the square size that we're going to have of 20 pixels. There's going to be 32 squares currently across our x-axis, 24 across our y-axis, so the screen width will actually end up as 640, the screen height as 320. Let's also add a few variables for the position of our snake. Snake x and snake y are going to be the position of our snake. Dx and dy will come on to later on when we move our snake. This will be a kind of step movement. Let's now use those variables. The first one is to choose the screen width and screen height, so I'll take that. So that's the screen width. That's the screen height. And then we're going to come over here where we're actually drawing the snake. This is the first position of the snake. This is the second position, the Y position. And the snake has width and height of the square size. Now it's finally time to get our snake to move, and we're going to do that by changing the snake X and snake Y. As the keys are pressed, this is going to loop through about 5 times a second at the moment. So let's do that. First of all, we're going to set dx to 0 and dy to 0. That's just resetting them each time we come from the loop. Then what we're going to say that if the event key is a left key, then the dx is going to go down 1 square size. Likewise, if it's right, it's going to go up 1 square size. Like if it's an up key, we go what there, then remember it's going to go, the y is going to go up. Remember, y goes from top to bottom in this coordinate system. And finally, if we're going to press the down key, then the y is going to go increase by 1, dy is going to increase by 1. Now we know how the snake will step. Let's adjust the snake's x and y position based on that. We're just going to say if dx or dy does not equal 0, because you want it to be efficient, then we're going to say snake x and snake y, we're going to adjust them as that is. Hopefully now everything's going to work. Let's save our work. Let's run our snake game. I'm going to press the up arrow, left arrow, and everything's working fine. Fantastic. Our snake is now moving, but it still just looks like a square. To make it look more like a snake, i.e. 3 squares together, what we're going to do is implement the snake as a list of tuples. To do that, we have to understand what these data structures, lists and tuples are, and here is a short lesson on that. Again, we're using a Python notebook. A list is a mutable ordered collection of elements. Mutable means that once we've created it, we can change, we can add and remove elements. Ordered means that in this particular list, apple, banana, cherry would be a different list to cherry, banana and apple. We create a list by putting square brackets at the start and the end of the list. So here I'm creating a fruit basket, a list of 3 elements, apple, banana and cherry. I can also create different types. Here's a list of integers called points. We can work out the length of the list by using the len functions. There's 3 elements in our fruit basket. We can find individual elements by using this indexing notation with the square brackets. Python counts from 0. So 0 would be the first element, the apple. Python also counts back in negative numbers from the last element. So -1 would be the last element. In this case is cherry. I mentioned that lists were mutable. That means they can be edited. Once we've got that, I can append an item to the end. So I put elderberry on the end of a list. I can insert an item at a particular position. This position 0, so that will put apricot at the beginning. And I can remove an item various ways. Pop is one way. Without an argument, pop will remove the last item. Here's the fruit basket once we pop the elderberry, without the elderberry. Finally, there's a lovely way of looping through lists. We can say for an element in the list, and we can loop through that way. Very quick look at tuples. Tuples are like lists, except they are immutable. That means that once we've created it, we can't add to it, we can't append, we can't pop, and so on. We create tuples by having a round bracket at the beginning and on the end. So here's an example of creating a tuple. And another example, again, we can use the indexing notation to bring back an element, in this case the first element in the digits tuple, which is 0. Example of using lists and tuples in a very similar way to what we're going to do in our snake game, except I haven't got any of the Pygame functionality to keep it to its essentials. Let's say that we've got a list of 3 elements, 3 letters. Our snake is going to be a list of 3 segments, and we've created that list there. What we want to do is, as the snake moves through the board, we want these kind of letters to move through the alphabet. And the way that we're going to do that is we're going to create a new letter called D. We're going to put it at the front of the list by inserting it, and we're going to pop the final element, which is the A. So now we've got DCB. We can do the same again, and it moves through the list alphabet one more time. Now actually our snake is implemented as a list of tuples. The tuples are the kind of X and Y position, and so we've got something similar here. We've got a list, pairs, and each element of the list is a tuple of a letter and then the kind of phonetic equivalent. So let's create our first list. There we go, and we're going to kind of move through the kind of tuples in exactly the same way. We create a new pair, a new tuple, we insert it at the front, and we pop the final one. So now we've moved one thing through the list. Just doing it this way, inserting at the front, popping at the back, end is just a convention. We could have done it the other way. So let's have a look at pairs 2. We've got a list ABC rather than CBA, and if I run that to create the list, then we've got pairs 2. And if we were to append the new pair at the end and pop the first element, then we could move through the alphabet that way. Back in our main snake game Python code, and our first thing to do is implement our snake as a list. So I'll say snake equals, open bracket, snake x, snake y. That's lovely. That's our first element. That's just one thing. And what I'll do is I'll create a new tuple, which is snake x minus the square size, and also snake y. And then I'll create another tuple, which is again snake x minus 2 times the square size, and again we'll have it snake y. So 3 positions all in the center, one to the left of each other. If there has been an arrow key pressed, we need to come down here and we need to create a new head for the snake. So let's call it snake head equals the new snake X and snake Y. That's lovely. I'm going to add the snake to the front, and I'm going to remove the last one. Don't need that. I'm just going to say snake.pop. That's good. So we've added a new head and we've removed the tail if there's been a movement. The last thing that we need to do is to change this so that we loop through each segment of the snake. Instead of drawing a single rectangle, we want to draw a rectangle for each segment of the snake. So I can type in 4, and the AI is helping me. That looks good. I'm going to draw a rectangle for every segment of the snake. That looks good. I'll get rid of the old code there. I'll run it, and now we can test it. Let's see how our snake game works at the moment. If we run it, we can see we've got a snake which is 3 segments as the initial snake. If I press the up arrow, we see that our snake is moving. If I press our left arrow, so that's good. Problems for a future lesson. First of all, when we click on an arrow, we move a step in that direction. Really, we should kind of start it moving that direction at a constant speed. Secondly, what we can do, if I'm now pressing the up arrow, the snake can go over itself. So once we're going down, we shouldn't be allowed to go up. When we're going to the left, right, and vice versa. Thirdly, the snake can go off the edge of the screen and it can come it back. But really, we want to kind of reset the game or something when it goes off the edge of the screen. Finally, our snake is very hungry. It needs some food and it needs to grow. These are all problems for another lesson. I look forward to seeing you on that one.